Of questions from homeworks. Obviously, nothing is due today, but if you have questions on stuff, be happy to take a couple. Ava?
Number 5.
From section 1?
Yeah.
Sure.
Okay.
Okay. So it says the number phi is equal to 1 plus root 5 all over 2. It's called the golden ratio and is related to the Fibonacci sequence. Great. Calculate phi correct to 2 decimal places and then 3 significant figures. Okay? So I'll fire up my calculator. What I'm going to do here is I'm going to press alpha and y equals to start. That opens up the fractions menu. From there, I'm going to pick the first option. That's going to give me the horizontal fraction bar. Massively easier to type things into your calculator if what I'm typing in looks exactly like it looks on the sheet of paper, so I don't have any worry about parentheses and that it's doing the right thing. So I love that horizontal fraction bar. So I'll just type that in the rest of the way. Okay. So correct to 2 decimal places means I'm rounding here. Correct? So that means I'd write 1.62. And if I want 3 significant figures, well, it's the same thing, right? Ava, you good? Okay. It says in part B, it says if we use 1.618 as the exact value, what is the percent error if we approximate at 1.6? So I'm going to type this into the percent error formula. So I'm going to go get my absolute value. So I'm pressing math. I'll go over to number. ABS is absolute value. And then there's a fraction in there. So I'll do alpha, y equals, first option. And I'll do the approximate minus the exact over the exact times 100, times 100, enter. And then if you skip C, that is totally fine because it's like a enrichment question. Where it says research the golden ratio and explain how it's found in nature, art, and architecture, you don't need to do that. If you did it already, good for you. You got a little bit smarter than you were yesterday. But if you hadn't done that yet or you skipped it like, ugh, does he really want me to do that? It's the spiral. Yeah, I saw it. Good job. Ava, are you happy?
Yes.
Joey? 7 in the same section? Cool, yeah. It says the diagonal D of a rectangle with length L and width W is given by Pythagoras' theorem, D equals square root L squared plus W squared. A rectangle has length 18 and width 10, both correct to the nearest centimeter. Calculate D correct to 3 significant figures. How many significant figures would be appropriate for this calculation? All right. Okay. So I assume the first one, all I'm doing is plugging in here into my formula. So I'm just plugging in W and L into my formula. Oops. Well, there's some typos there, Kulik. There you go. Press enter. So if I do this to 3 significant figures, I'd have 20.6. When it asks how many should be appropriate for this calculation, I would think 2, because I wouldn't think that doing a calculation I should get a measurement that's more accurate then either of the calculations there, which were both rounded to the ones place. I wouldn't think an answer with accuracy past the ones place would probably be what I'd want. I'd probably say rounding it to 21 with 2 sig figs is probably more appropriate. Does that make sense, Joey? Okay. You'll never be asked for a question like that on a test or quiz, just so you know. It says find the difference between the maximum and minimum length of the diagonal of D. So this is a little tricky here. So to do that, what I would be doing is I would want to write a range for L. And then a range for W. Is that okay there? Well, because I have the strict less than, that covers the first number that's less than 18.5. So like 18.4999999, it doesn't actually include 18.5. And now what I'm going to do to find the difference between the maximum and minimum lengths for D is I'm going to use this to calculate the minimum for D, and I'll use this to calculate the max for D, and then I'll just subtract those two numbers. Does that feel okay? All right, so I'll do square root 18.5 squared minus 10.5, plus 10.5 squared. And then move outside the radical and then do minus square root of 17.5 squared minus 9.5 squared. So there's my difference between the minimum and maximum is that 6.57 number. In part C, it says an estimate of D is given at 20. Find the and the exact value is the maximum found in part A, correct to 3 sig figs. Okay, well the maximum from A would have been that first calculation that we did here that I didn't bother, that I now regret doing all in one line. Oh, goodness gracious, come on now. I forget you. I'll do it all over again, that's fine. They've, so this is my, that's what they're saying it to use for the exact value. So now I'll just do that percent error calculation. So math, number, pick that absolute value, alpha y equals, pick the fraction bar, approximate minus exact. So to get this number, I can just press elf or second and the negative sign. That'll give me the ants, which is just the last answer that popped up in your calculator. Or you could like scroll up there, but sometimes it's funny in a fraction about where it wants to put that previous answer, so I like to use that ants command because it gives me a little bit more control. And then times 100, so 598%. Huh? For number 7. Oh, I see. Find the exact, okay. So it says the exact value is this maximum from part A used with 3 sig figs, so it should be 21.3 there and not use the whole thing. Maybe that's the issue. I don't know. Joey, the other thing to keep in mind with this textbook is the answer key are just like a typograph, like an error fest in there. Like the editor just did a really poor job of editing this textbook. So it is strewn with mistakes. So keep that in mind. If like I did something and I think it's right and it is an answer, like that just makes no sense how that got there. That's going to be my guess. Now, the other possibility here, unless somebody has a good reason as to why they think something's wrong, do you have a good reason?
If it's doing it from part A, would it be just 18 and 10, about 0.5?
Well, it says is the maximum value found in part A. So if the maximum value of this is near a centimeter, I should be using those. Well, it says rounded to 3 sig figs. So like, you know, like I think it probably, looking at this, I bet it means minimum, that if I did the minimum numbers, I bet I can get that answer from the back that Joey just quoted. Let's try that real quick. Geraldine, what's up?
So for B, it says like 1.4 instead of 5 whatever it was, but like when I did it, I got the right answer. I don't know what happened.
That you got 1.4?
Yeah, and I got, instead of 2.9, I got 3. So like, I think it's right, but.
So there's that. If I do this with 19.9, I wonder if that gets me the right thing. I don't know, Joey. Here's the thing. I'm not going to ask you anything that's like this nested inside of like, did you do this right or wrong? Like if you goof up one part, like every subsequent question is going to be wrong after that kind of thing. Like this is one where you screwed up part A and like everything afterwards is going to be kind of goofed up from it. But I think the description of our process that we're using here is correct. And I don't know what's the matter. 2.5. Yeah, that seems okay. And then to 10. Yeah. I don't know. Nate. Of course. I don't know why this isn't working out, but like we get the idea, right? Okay. We'll just go with good enough. Geraldine, if you figure out what you did and to get the right answer, I'd be happy.
I just put in my calculator and I got the right answer, so I don't know.
Yeah, I don't know.
It might have been, I don't know.
Yeah, I looks, you know, like from what I did, I don't see.
No, I didn't get C, I got
20.59.
I like it as 2 separate, like I thought the minimum maximum subtracted, but 2 separate like equations. I didn't put in one.
Oh, you think that they just took the rounded answer and then did the bounds on that?
Oh yeah.
This is so horribly worded then, because I am so confused as to like what their numbers were supposed to be using, because that's not, to me, that's not what it said to do, right? Like that's not the maximum value for part 1. That's just your answer to part 1 or part A, right? Like the maximum value from part A would be that number that I computed earlier, that 21.9 or whatever. But that's not what they want us to use. I don't know. I'm at a loss. Poorly worded question, Joey. We'll chalk it up to that. I think we've done enough here that I think everybody understands like what we're supposed to be doing, or the point of like doing this. Actually getting the answers from the back of the book is sometimes an adventure. So again, I think this got edited and nobody updated the question, is what it looks like to me.
So would you find the difference between the maximum
I think the way we did that is the way you should do that. So what I did was I wrote the bounds on each measurement, and then I calculated D using each measurement, which is what I did here. So I did 18.5 squared, or square root of 18.5 squared plus 10.5 squared minus square root 17.5 squared plus 9.5 squared, and just looked at the difference of those, because I think that that is the maximum measurement for D, and the minimum measurement for D would be like, okay, what's the biggest that W could have been, and the biggest that L could have been, and the smallest that, you know, and smallest, and that's how you get the minimum maximum values for D. But if that's not the number in the back of the book, I don't know what the heck they would have been doing there. It's a mystery to me. Atala? Problem 8, you said? Okay. Yep. All right. Is everybody satisfied with like the discussion we've had for part 7 anyway?
Yes.
Or number 7? Yeah, I hope so, right? Okay. Now, Tala, you just wanted to look at part D, you said? Or C and D? What did you say?
Yeah, C and D.
Okay.
Wait, I have a question.
Okay.
So for the difference of 7, we just add like the max and then add the minimums and then just
So
subtract them from each other.
what I did was I calculated D using those two numbers, and then calculated D using those two numbers, and subtracted.
And then
That's your difference between the
okay.
minimum and maximum Ds. Is that good enough?
Yeah.
Okay.
Can we also do B of 8 too?
Okay. Maybe we'll just do all of 8, just in case. All right. I probably need A to do something. All right. It says the cuboid has length of 0.89, correct to 0.01, width of 2.1, correct to 0.1, and height of 2, correct to 1. It says write the bounds. Okay, so my length could be 0.885. And then less than 0.895. Oops, let's use L though. Everybody happy there?
So for all of these like bound questions, so you're pretty much just like taking the last number and then you're subtracting it by like 0.05.
Taking the last, yeah, basically. Yeah. Oops. It's the wrong side. 2005 to 2.15. And then the height is 2, correct to 1. So, oops. 1.5 less than h less than 2.5. Is everybody okay with this? To get the bound, I'm going to calculate the volume once doing this with those numbers, and then the volume again using those numbers. Hopefully remember the volume for a cube is just length times width times height, right? If you didn't, don't worry if I asked you to do a calculation to get a bound on a value. I would give you the formula in the problem. And I think they really should have here also, because that's the expectation. And if you're writing an IB book, you should be writing questions with the IB expectations of like, you will give you these numbers in the problem. So that's my low bound for the volume. And this one should be the upper bound for my volume. I'm going to just round this to 3 sig figs then. So 272 less than or equal to V less than, what was the other number? 481. It then says in part C to estimate the volume of the cuboid. So my estimate would just be using their rounded values. And I'll call that A for approximation. And it says, calculate the percent error between your estimate and the dimensions given. Wait a minute. I just used the dimensions given. Estimate the volume. Again, like you see the issue with some of these questions, they're just bad. Like, who edited this? Like, what does this even mean? So Alessa, I see the issue with C. Like, I don't know how you're supposed to, what estimate we're supposed to be using. Does it just use the maximum to do this percent error? Yeah, again, this is one where it's like somebody edited this and then didn't update any of the answers. Like, I firmly believe that this is what's happened. It gets better as it goes on. It becomes less of a problem. But this early chapter in particular is just like riddled with problems.
All the chapters like this?
This one is particularly bad.
When does this chapter end?
It's only got 4 sections. And it gets better after these first. This section, I think, if memory serves, is particularly bad because of, like, I think they redid. Somewhere along the lines, they're like, oh, we should do some problems where you have to, like, we give you some bounds for measurements and you have to do some calculations with bounds and get a bound for the new calculation. And then they, like, I don't know. It's hard to.
So are there gonna be like more questions like this?
Oh yeah. More questions like this. They get better as it goes. I promise. It's not. There's still, like, I think questions that are like, but it gets better. So I don't know what to tell you. I wish I had. Yeah. If, like, again, your homework isn't graded right or wrong. Okay.
Are the tests going to be like this?
No, I wrote the tests.
Oh.
Is there gonna be study guide?
Okay. No, but I'll tell you exactly, like, what to expect. It won't be bad.
Is there going to be?
Oh no, usually. I mean, like. Now, I don't know what the heck you're supposed to do with C, but Alessa, we can do D because we do have our volumes. So if it wants a cost range, all I'm going to do is take each one of these numbers that are cubic meters and multiply it by the 50.75, and it'll give me then a bound for my cost. Does that? I don't know what we're supposed to do with C. It's a mystery to me. Okay. And it at least should feel reassuring that you're like, I don't know what the heck to do with this. And Mr. Kulik reads and it's like, it's a terrible question. You should know what the heck to do with this. Because I don't know what the heck to do with this. Nora. Of course. Yeah. So for part D, all I did was take that 150.75 and then multiply it by my volumes. Like that. At least that's what you're looking for?
Yeah.
Okay. Yeah, no problem. Okay. Who wants to grill me some more on the homework? Who's next? It's okay. Like, I think this is a positive experience, right? Like, everybody hopefully is feeling much better about themselves as to, like, I couldn't get Boo Diddley to work out, and it's like, there's issues.
Yeah, I just have a question on, like, the balance stuff. So it's like, if it's to the nearest, like, correct to the nearest 0.1,
Mhm.
then
That's telling you that that's the digit that was rounded, was the 0.1.
so the
So the hundreds place. So either we rounded up from like 88.5 or down from just under 89.5.
yeah, so if it, like let's say the middle is just 0.1, like the one on the left would be 0.05 less than equal to.
Okay. Oh, hold on. Okay, what are you telling me? Our,
So the middle term is 0.1, and it's the hundreds place. So it would just be,
so this is correct to this?
yeah.
Okay.
And so the left side would be 0.05, and then it would just be 0.15 or no 1.5.
Yeah. Yep, exactly right. Yes,
Can
Charlie.
we do like 12 on 1.2? Because I don't really know what they're asking. It's another like.
Awesome. I love the weirdly worded questions. 12 on 1.2. Happy to do it. Okay. It says use the repeated multiplication model for exponents to show that for m greater than n and a not equal to 0, that a to the m over n is equal to a to the m minus n. So this is the idea. So I know that an exponent is repeated multiplication, right? So a to the m means we've done a times a times a. I'll do a little ellipsis. Times a, m times, right? And a to the n means we did a times a times a times little ellipsis, all the way down times a, n times. Okay with that? And now, every time I reduce, I can reduce one from the bottom and one from the top, right? So I can, if I reduce all n of these, I'm removing n from the top. So I'm left with a times a times a times m minus n times, which is just a to the m minus n. That's all it was trying to get you to do. It's like, think about how we would prove this. And the way you prove this is just like, what's the definition of an exponent? You just cancel, cancel, cancel. Canceled n of these from these m. I'm left with n minus n of them. Oh, that's all I need to do. Of course. Again, would you ever be asked to do something like this on a quiz or a test? No. No. All right, last chance on questions. Beautiful. And again, anything that I've written down here or I've talked about or I've shown you on the calculator, all of it that I've written down is in the OneNote. So if you need to go back and look at anything from the OneNote, it's all still there. Or if you want to rewatch anything to see what I did on the calculator, it's all still there. Okay? So no panicking there. All right, today we're going to rip through sections 3 and 4. And we'll talk about the upcoming quiz and or test. Section 3, it's about scientific notation. All right. So if we change a decimal number to a scientific notation number, say like 5,120,000, the decimal point for 5,120,000 is here. And to get it to scientific notation, I'm going to move the decimal point 1, 2, 3, 4, 5, 6 times. So that means I would have had 5.12, and then I have to multiply it by 10 6 times, or 5.12 times 10 to the 6th. if we have a small number like 0.00684, the decimal point is here, and I need to move it 1, 2, 3 places. So I have 6.84, and then because I'm moving my decimal point to the right, I'm going to be dividing by 10, so I moved it 3 places, so I divide by 10 3 times. I remember that dividing by a number is same as multiplying by a negative exponent. So I have 6.84 times 10 to the negative third. You guys all know that your calculator will convert a number into scientific notation for you also. Let me show you how to do that real quick. So if I take out my calculator, if I change my mode from normal to scientific, SCI is to scientific, and then I go back to the main screen. If I just type in the number like 5,120,000 and press enter, it just puts in scientific notation for me. Or if I put in 0.00684 and press enter, it just puts it in scientific notation for me. So like, clearly I expect that you're able to do this by hand, but like, if you're ever confused, you can just change your calculator's mode to scientific, type the number in, press enter, and it'll convert it to scientific notation. And we can do vice versa. We can go from scientific notation back to a decimal, right? So if I have times 10 to the 6th, I'm just going to be moving this decimal point 6 places. How could you, if you wanted to do this on your calculator, you just switch the mode back to normal. And you can type in 5.16 times 10 to the 6th and press enter, and it gives you it back as a decimal, right? Sorry, my voice is starting to go a little bit on me from all the talking this week that I wasn't used to, and I have my vocal cord calluses all built up. And I can do the same thing, obviously, with a small number, right? Doesn't matter. Everybody's cool? No big deal. Scientific notation, you're like, whoo! That's a nice change, right? All right. That's it for section 3. It's just scientific notation. Like, come on, guys. We've done this, you know, like in a bunch of science classes you did in like middle school math. It'll be all right. Everybody's good? Okay. If you had to do a calculation in scientific notation, like 2 scientific notation numbers you have to multiply together or something, how would you do that? Just do it on your calculator. You know, just put it in. Yeah, just do it in scientific notation mode on your calculator and just type it and press enter, right? All right. Section 4 is about exponents and logarithms. We already talked about exponents a little bit already, so not overwhelm you on that part, but we'll move along. So we have our basic properties of exponents. We listed these earlier, right? So I'm not going to like belabor going through these again. We listed all of these earlier. But these are things you should know, right? Not to write them down, but if I give you an exponential expression and ask you to simplify it, you should be able to use these properties to simplify something, right? Like if I have x squared times y to the 3rd and then parentheses to the 5th, you should be able to simplify something like that, right? No big deal. Like this is like algebra 1 again, kind of again. Yeah, it's true. All right. Basic properties of logarithms. Who remembers the definition for a logarithm?
It's like the opposite.
Yeah, that's pretty good. So we can define a logarithmic equation with an equivalent exponential equation. So the base of the exponential becomes the base of the logarithm. The output of the exponential becomes the input for the logarithm, and the exponent of the exponential is the output for the logarithm. If I take the log of something, what I'm doing is finding what exponent of some base b gives me this answer, right? So that's our definition for a logarithm. And then some basic properties, provided that b and x are positive and b is not equal to 0. The base of the logarithm, since it's equivalent to a base of an exponential, the same rules apply, that has to be a positive number, not equal to 1. The x has to be positive because hopefully we remember that you can't take the logarithm of a non-positive number. So log of 0 is undefined, log of a negative is undefined. Just can't do those. So log base b of 1 is always equal to 0 because that's equivalent to saying b to the 0 is equal to 1, which we know is a property of exponents. Log base b of b is equal to 1 because that's equivalent to just saying b to the first is equal to b. Okay, sure. Log base b of b to the y is equal to y. Well, that's true because that's really the same thing as saying b to the y equals b to the y. The way I think about it, though, is that log base b is just canceling exponent base b. And you're left with just the exponent. Or that we have b to the log base b of x power is equal to x. That's equivalent to just saying log base b of x equals log base b of x. Or the way I think about it is exponent base b is canceling log base b, leaving just the argument from the logarithm. You guys, we've done logarithms, I think 2 years in a row. You do them in Algebra 2 and then again in trigonometry pre-calculus. So this shouldn't look unfamiliar, but it's good to review it again because this is usually like one of the least remembered pieces of Algebra 2 where it's like, what do I do with a logarithm? What does this really mean again? So we'll do a little bit of exampling here. There's two special types of logarithms that get a special name. The first is the common logarithm, which is just log base 10. We choose not to write the base of 10. We just write log and understand that there's a base 10 there. So if you see log with no subscript, that just means base 10. The other special logarithm is the natural logarithm, which is just log base e, but we don't write log base e, we write the letters ln for natural log, or logarithm natural. I think it was a French notation. Those kooky Frenchmen. Everybody's okay with remembering common log, natural log, just a notation that these are things? Okay. So on your calculator, if you look at the left-hand side, we have a log button and natural log button built in to our calculator. So let's do a little bit of practice just evaluating some logarithms. Now, I recognize you can just type log of 100 in your calculator and press enter. Let's use this as an opportunity to practice using our definition of logarithms or some of our properties of logarithms to do this. So if I'm going to use the definition, I'm going to start by saying, okay, log of 100, I need to write that as a logarithmic equation. So I'm just going to say the answer is like equal to x. And now I'm going to do my definition of a definition of logarithm to convert this to an exponential equation. So I remember the base for my logarithm is 10. So when I do this, 10 becomes the base, x becomes the exponent, and then the 100 becomes the x. So I have 10 to the x equals 100. I recognize that 100, if I rewrite this as a base 10 number, is just 10 squared. So if I have 10 to the x equals 10 squared, what's x have to be? 2. So log of 100 is just 2. You just looking for a fist bump, maybe? Okay, that's all right. Let's do another one. Let's say we have log of the 5th root of 10. So I start the same way. I set that equal to x, so I make a logarithmic equation. I recognize that there's a base 10 there. I apply my definition of logarithm to say 10 to the x is equal to the 5th root of 10. I remember my properties of exponents, that a 5th root is the same as what exponent? 1/5, that's correct. So I have 10 to the x equals 10 to the 1/5. If I have that, what does x have to equal? 1/5. And that's my answer. Just jogging some memories. No big deal. Yeah. Usually it's okay. Let's do another. Say we have log of 1 over 1,000. Start the same way. Make an exponential equation. Recognize that we're base 10. Apply my definition of logarithm to say 10 to the x equals 1 over 1,000. Now I want to rewrite 1 over 1,000 as a base 10 number. Well, I know that 1,000 is 10 cubed, and 1 over means just I have a negative exponent. So I have 10 to the x equals 10 to the negative 3. So x is just negative 3. There's my answer. Again, I recognize all of these problems you could just type into your calculator and press enter. The point is to kind of review these properties of logarithms a little bit, right?
On a test, will you make us write it out like this, or can we just use our calculator?
Depends on the direction. So if the direction says use the definition of a logarithm to blah, 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 then you need to kind of write it out. If it just says solve or evaluate, you're free to use your calculator. Ooh, what about this one? 10 to the log of 6. Well, I'm going to start by turning this into an exponential equation. It is 6, I know. I know, you all know. And then recognize that we have a log base 10 there. And then there's another log base 10 there. And then x has to be 6, but it sounds like the vast majority of us were like, that's 6, which is great. I'm super happy that we're on the ball and have had appropriately jogged memory. Oh, so I had one more line there. Great. That was super important. Log of x is equal to 4. So that's already a logarithmic equation. Recognize it's base 10. I use my definition of a logarithm, so I have 10 to the 4th is equal to x. 10,000. Ah! It's hard. Get ready, hold on. Log base 2 of x is equal to 5. It doesn't matter. You're still just using that definition of our logarithm. So that becomes 2 to the 5th equals x. 2 to the 5th is 32. You type that in your calculator if you didn't know it offhand. The computer people among us probably knew that 2 to the 5th was 32. Because computer memories are all base 2, because binary, right? Or no? No, that's okay. You learned something new today. Do you know why binary works, like electronically, what's going on? Remember from your chemistry class when you guys talked about like the quantum model of the atom? That electrons have two spin states, spin up and spin down? That corresponds to the 1 and 0 in binary. That's neat. You wish you're over there with the clapping. You guys can applaud for me anytime. Yeah. Thanks. That's fun. All right. The other thing, or another property of logarithms along the way that we haven't talked about yet, was the change of base formula. Now, this was super important when I was a math student because the calculator I used as a math student didn't have a logarithm button on it. You know what I had to do? I had to look it up in a table in the back of the textbook. So if I had to like log base 2 of 5, I looked up log of 5 and log of 2, and I plugged them into the formula, and I typed in like the decimal, divide by decimal in my calculator and pressed enter. It's a gigantic hassle. It's very nice, the world that you live in. Because on our calculator, you have the option to write a log of any base, right? So if I press the math button and I scroll all the way down to the bottom, I see the log base command. So I can do something like log base 2 of 5 right on my calculator. Notice that this would be the same thing as doing like log of 5 divided by log of 2. Like I'm using the change of base form. I forgot to type log again. Or natural log of 5 divided by natural log of 2. Right? They're all just giving me the same decimal, right? Now, which one are you going to do? Aren't you just going to do the log base on your calculator? Like, let's not be like, don't be coy about it. Like, do the easy way. Okay. So we did that. We said, yeah, if we do the change of base, typically we pick A to either be 10 or E because we have the log or the ln button already built in. But in practice, like, just use the log base command, man. Like, that's all there is to it. Everybody feel okay? Yeah? All right. So that concludes sections 3 and 4. I know. Pretty exciting. Your assignment for sections 3 and 4 is on my Notre Dame. I've made a... this assignment would not be due until, not this Sunday, but next Sunday. I try to leave always one class period in between anything being due, so if there's questions, you have a chance to ask about stuff. So this Sunday, all that's due is section 1.1 and 1.2. Sections 1.3 and 1.4 wouldn't be due till the following Sunday. Now, you should do them because section 4 was the last section in this chapter, and we have a quiz planned for Tuesday. That's next class, Tuesday. Let's talk about what I'm expecting to be able to do on said quiz. Sound good? So, you should be able to, given a number, determine what set or what number set it belongs to. So if I say the number is 7, your options are natural number, integer, rational number, real number. Pick all that apply. It's all of them, right? It's a natural number, it's an integer, it's a rational number, it's a real number. You'd pick them all, right? You'll have some questions like that where I give you some numbers and you pick all the sets that apply. Everybody's cool with that? Pretty straightforward. Okay. As an aside, when I write down the number sets, I'll use like the symbol, like the N and the Z and the Q and the R symbols for natural number, integer, rational number, real number, just so nobody's... you should be able to calculate a percent error. I will give you the percent error formula. You should be able to do basic number operations like add, subtract, multiply, divide, or exponents with a number in scientific notation. You just use your calculator to do it, right? You should be able to convert between Celsius, Fahrenheit, and Kelvin. I'll give you the formulae to do that. Should be able to do a basic unit conversion and also like take that number and then do a calculation with it, right? Like convert like feet to inches or something. Okay. Should be able to simplify exponential expressions like x squared times y cubed all to the fifth or something. Should be able to solve exponential equation like some of the stuff we just did there a second ago, where you can use a logarithm or you can rewrite as a logarithmic equation or whatever. We've seen a couple of ways to do that. You should be able to take a given number and round it depending on the instructions, like to 3 significant figures or to the 10th place or 4 decimals or, you know, whatever I might say. Is that okay? And then you should be able to give the bounds for a rounded number. We did a bunch of practice like that. It seemed like most of the questions at the start of class were from homework regarding writing the bounds for things. That's what your quiz will look like. Does that feel pretty doable? It shouldn't be too hard. Given that this is the end, section 4 is also the end of the chapter, I have an option for you. We can take the chapter 1 test on Thursday next week, or we can start the next chapter and do it after Labor Day weekend. I'll ask you again after the quiz on kind of what you feel like doing. Okay, so I don't need a decision now. I'm just going to let you sit on it. Maybe after taking the quiz, you'll have a different opinion than you do right now. But we'll cross that bridge on Tuesday. Remind me that we need to do that because I might forget, but you probably won't. In the grade book, I put the test on Thursday, but it doesn't have to stay there, right? If after the quiz on Tuesday you decide like, yeah, let's just do this after Labor Day, that's fine. I'll move it then. You know, in fact, I like to give you a little bit of ownership on stuff, on when stuff happens, because I know that, you know, some of us are extremely busy and overloaded with activities and sports and classes and whatever else, and I'm trying to be sympathetic to that. If it matters to you, the test format is also up there. It's basically the exact same thing as the quiz. It's just kind of longer. If you want to read through it, you can, but it's there as well. If before Tuesday you want to look at that to help inform your decision, I don't know if it'll make any difference or not, but you're welcome to look at it. That's it for me today. You can take the remainder of our time, the next 30, 40 minutes or whatever's left, 20, 30, 40, I don't even know anymore. You start on the next homework or problem set or this one. We need to talk about how to get, if you're writing on paper, getting your homework into OneNote, right? So if you look at your, Adriana, I'm going to pick on you and look at your book. So like if you go to the homework tab, you'll make a tab, and Adriana's labeled her tab. That's really wonderful labeling, like listed the homeworks that are going to be viewed there. She took a picture with her phone, it appears. That's great. You emailed it to yourself or something? Or and then just dragged it in and dropped it in. Yeah, perfect. Yeah. If you have OneNote on your phone, you could do it directly on your phone. That's fine. But that's all we're talking about doing. If you have major technical problems, we can talk to me on Tuesday or whatever, and I'll walk you through how to do it yourself if you didn't get it, if you couldn't figure it out or whatever. But it's basically just like you take a picture on your phone. Use your phone and not your tablet. The resolution is on the tablet camera is god-awful. I probably won't be able to read it. Use your phone and then just get it in there however is easiest for you. I'm not picky about the format that you use. Yep. The one thing I will say, if you're doing this, if you're going down this route, you've imported some image into OneNote. Before you close OneNote, take your mouse, go up here where your notebook name is, pick sync status, and make sure you sync all your notebooks before you close out. Wait for all the status bars to go full green, because the most common cause of a missing assignment is somebody dropped the big picture file in there and then didn't sync their note, or didn't give their notebook time to sync before they closed out. And I go to look and it's not there because it hasn't made it, it's got to go up from your tablet to the cloud and down from the cloud to my computer, and it takes time. But that's it for me. Are there any questions for me? Concerns, comments, criticism?
No, can I see the folder with homework and upload it now, or should I just wait?
I'm gonna turn over here and just contemplate the universe and not pay attention to what's happening for a few minutes. How's that sound?
That sounds really
You get what I'm saying? All right.
Yeah, let's look at that. My calculator. Oh, okay.
Yeah.
The answer is 1,000%. I don't think they can. Are you still upset? Are you still upset? So the answer is 7, sophomore 7, and this is yeah. And their answer is dropping off.
No, we tried.
I got drugged. Grace, you got one.
No, not.
No, I think you would stop.
Oh.
Your phone.
The answers come to me. Amazing.
Dude,